The Barcelona Supercomputing Center, BSC, is the national supercomputing center in Spain. Besides providing supercomputing services, BSC does research in computer science, life science, and earth science. In mF2C project, the Barcelona Supercomputing Center contributes with two research groups, the Storage Systems Research Group and the Workflows and Distributed Computing Group. The main area of interest of our groups is on new technologies for storage and programming models for distributed computing platforms. The Storage Systems Group has been developing DataClay, an object-oriented storage platform that enables storing, access Java and Python object codes transparently in any location in the system. The Workflows and Distributed Computing Group has been developing PyComs, a task-based programming model that enables to parallelize applications and to execute them in distributed computing platforms, including mobile devices. In the mF2C project, BSC will focus on extending our platform for storage, DataClay, and programming model comps to see how to better integrate data access with the programming model to meet the distributed and volatile nature of the fog-to-cloud infrastructure. The challenge in this research are mainly related to the heterogeneity of the devices in such infrastructure, from sensors to computers in the cloud, that may appear and disappear at any time. We aim to provide a programming model platform integrated with a novel data store that makes applications agnostic of the actual computing platform. For achieving our goals, we will consider using ideas from the high-performance computing world in the Internet of Things world.
Hi, my name is Admela Jukan and I'm professor of electrical and computer engineering at Technische Universität Braunschweig in Germany. In this exciting project, mF2C, where the idea is to connect clouds with smaller, closer to the user and devices, networks, of course, our major interest is in two areas, communication protocols and applications of machine learning in combined fog-to-cloud systems. Now, the first area, the area of communication protocols, is very exciting to us, especially in the area of application layer protocols, where established protocols and rather old protocols like MQTT, message queue, telemetry transport are experiencing their revival in this new system and together with the new exciting protocols like RESTful HTTP. The challenge of these protocols is being able to working well both with the very tiny IoT devices everywhere in the pocket, at home, and so on. These devices have significant resource constraints and clouds, and at the same time stay secure and fault tolerant, and of course open source development, which is important to us in this project. Now, the second area of machine learning, which our team is also investigating in the project, is really about applications of machine learning in this kind of system, which means we use machine learning something like as a tool to achieve some really important goals in the project and also interesting, such as computational resource demand prediction, intelligent leader or backup selection for clustering in fog computing, and of course optimum resource allocation in the system. In the last 2 decades, we've seen a growing public interest in the IoT applications of all kinds, from smart cities, today a lot in digital agriculture, and also transportation, of course. These factors that are societal and economic in nature have led to the development of a lot of smart applications, which now can take advantage of the combined fog and cloud systems as in our project. The key innovation in our system is the ability to embrace novel computing architectures, while at the same time enabling scalable data sharing, analysis, and correlation, which is relevant to applications not only for businesses, but also for applications for ordinary citizens. Thank you.
I'm Jens Jensen from Science and Technology Facilities Council, which is one of 7 research councils in the UK. And the mF2C project is building IoT infrastructures, and the role of STFC is to build the security and analyze the security of the devices. And IoT security is, of course, quite challenging because there have been lots of incidents that have been mentioned. Incidents that can be both embarrassing or expensive or both, where you have botnets of devices, you have devices that come out of the factory with vulnerabilities in them. So it can be quite challenging, and in general, the users of the infrastructure must trust it, and it must be trustworthy, that we don't actually lose data, that we don't compromise their the data that they entrust into the infrastructure. And it's actually really challenging when users can bring their own devices and start up easily, connect easily, and so can the bad guys. They can bring a compromised device, or they can build their own thing with their own protocols and try and see if they can get information out of the infrastructure. So security has to be sufficient to meet the protection that we require, because if there is no security required for particular types of data, then it doesn't make sense to encrypt it because it's just too much overhead. Conversely, if data does need to be protected, like personal data, sensitive data, then it does need to be encrypted and protected so that it can be unlocked only by the intended recipient. And this is even more challenging because some of the devices are lightweight, so they haven't got the computational capabilities of a laptop or a desktop PC. So we need to make sure that things work on devices and that the protocols that are used are usable, that people don't get frustrated and walk away. They also have to follow open standards so they can be interoperable with other devices. And then we had other additional challenges like the GDPR and scalability. How do you scale to a very large number of devices? So it should be interesting. Follow us and see what we come up with. Thank you.
My name is Chai Masip. I am in the chair of the CRACS Lab. The UPC team involved in the mF2C project is part of the CRACS Lab, a research center created in 2008 at the UPC and located at the Vilanova campus, a seaside city 30 kilometers south direction from Barcelona. The CRACS Lab puts together a multidisciplinary team, including researchers and faculties from the UPC and the Hospital Clinic de Barcelona, one of the most relevant hospitals all over the world, so bringing together background in networking, computer architecture and systems, maths and health. The team involved in the mF2C project has a large track record of more than 20 years of research activities in the networking field, visible through the participation in many research projects, be it at national or EU level, contracts with industry, solid collaborations with well-reputed companies in the area, and a large list of publications coming from the research initiatives, new ideas, and obtaining results. The CRACS team is one of the main authors of the Fog-to-Cloud concept, and is in the role of scientific coordinator, is highly interested in contributing to the mF2C project, especially in two main areas. First, we are putting efforts in an out-of-the-box solution design for the whole system that may be seamlessly deployed in any system, device, or component, with no dependencies with any existing solution or technology. Particular interest will go to both the design of the hierarchical management approach, defining first the different roles devices may play, and second, the layers the architect may consider, as well as the design of the set of resource management actions, including naming, discovery, resources topology, and the policies to manage clustering, dynamicity, and volatility, as well as to the entire Fog-to-Cloud functional blocks architecture. Second, we're also working on the definition of the collaborative model envisioned for the mF2C system, including policies and potential business models. To that end, the team includes a set of developers that are all working towards a prototype to be deployed into recently developed testbeds at the lab premises, consisting in a close-to-reality smart city implementation.